So question 51 from the homework, we're given this reaction. 2 molecules of sulfur dioxide react with oxygen to form 2 molecules of sulfur trioxide. That reaction occurs at 1150 Kelvin. And the free energy, so the standard free energy, the delta G for that reaction is 77.9 kilojoules. What's the equilibrium constant in kilojoules for that reaction? So to figure that out, right, we're back to that same equation we used. Delta G equals delta G standard equals negative RT ln of K. We know delta G standard, that is here. We know temperature, we know R, except for we have to convert R, right, into kilojoules. So 8.314 joules mole Kelvin. So to put R into kilojoules, 0.008314 kJ per mole Kelvin. All right, so delta G equals negative RT. You can start plugging things in. So my delta G is 77.9 kilojoules minus equals a negative R 0.008314 kJ mole Kelvin. Temperature 11,050 Kelvin times the natural log of K. Multiply those two together and we get, I have to do that. So 11,050 times 0.008314. I get 77.9 kilojoules equals a negative 9.5611 kilojoules, natural log of K. Divide both sides by negative 9.5611. Right, the natural log of K equals, so 77.9 divided by that. Get a negative 8.14. And remember from when we were doing integrated rate law for first order, like how we got rid of the natural log, right? E to the X equals ln of X. So E to the negative 8.14 is going to equal our X. So E to that, and I get 2.89 times 10 to the minus 4. Right. There shouldn't be any units on equilibrium constant. Equilibrium constant's unitless, so I don't know why they asked to have it in kilojoules, but yeah, equilibrium constant. So 2.9 times 10 to the minus 4, right? That's choice B for this question. So I find it a little odd they asked because kilojoules cancels out right there when you divide, and when you do the natural log of anything, that's unitless as well. And equilibrium constant is one of the few things that we talk about that is unitless. So I just think it's odd that they say, what is the equilibrium constant in kilojoules for that? But we can find the equilibrium constant, not have to worry about the units of it. So 2.9 times 10 to the minus 4. This little trick from earlier in the years is probably like the hardest part of that step, remembering how to get rid of that natural log.